Problem number 1. Alright, it says the vertices of triangle QRS are located at these points. Joe wants to circumscribe a circle around the triangle. That means to draw a circle around this triangle, hitting each one of these vertices. But first he needs to identify the coordinates of the center of the circle. Use the grid to determine the coordinates. Now, the first thing you need to do is understand which one of those triangle centers will we be talking about. If I draw a circle around this triangle, if I draw a circle around this triangle, which one of those triangle centers am I doing? Why does it keep doing that, yo? Okay. This is actually kind of hard to do. If we look back at our notes, look at the special conditions at the bottom. The circumcenter is equidistant from the vertices, and underneath that it says if you draw a circle through the vertices, the center of the circle is the circumcenter. So isn't that exactly what we're talking about, drawing a circle through the vertices? So we're talking about a circumcenter. Now, then you look at what does it take to build the circumcenter. The circumcenter is made of perpendicular bisectors. Perpendicular bisectors. That means, looking at the picture here, if we draw lines that are perpendicular to the sides, right at the middle, perpendicular and bisecting, that should give us the circumcenter. So look back at this picture. If we were to build perpendicular bisectors, look at this side of the triangle, RS. Imagine that we had a perpendicular line right through the middle of this side. Where would that perpendicular line go? See this arrow right here? They've already drawn it for us. This line right here is the perpendicular bisector, right? Because you can see that it's perpendicular, and it's 3 to the left, 3 to the right. It's the perpendicular bisector. What do you think the other perpendicular bisector is? They've already drawn it in for us as well. This line right here that they already have drawn for us is the perpendicular bisector. Okay? Again, it is perpendicular. And look at the side. It's 2 up, 2 down. It's right in the middle. So it's a perpendicular bisector. So if I have 2 perpendicular bisectors, they should meet at the circumcenter. So in other words, this point that they're showing you right in the picture, that is the circumcenter. And that would be the center of the circle that we're looking for. So what are the coordinates of that point? 3, 2. So considering that they drew big arrows pointing right at it, that made the problem a little extra easy. But you guys should have been able to find that point, even if they didn't draw the perpendicular bisectors in for you. You should have known, you should have been able to draw those perpendicular bisectors yourself and found 3, 2 that way. Alright, anyway, that's problem number 1. Let's move on to problem number 2. A graphic artist plotted the triangular background for a design on the coordinate grid shown. The vertices are these. The artist plans to place an icon as the centroid. Okay, focus on that. It's got to be the centroid of the triangle. Now, I went ahead and copied it onto this paper, but in addition to all the other things we learned about the centroid, there's a formula that you can use to calculate the centroid if you have the vertices, if you have the coordinates. And the formula is right here. Basically, you take the average of all the x's, and that'll be the x value of the centroid. If you take the average of all the y's, that'll be the y value of the centroid. Okay? So if I want to find the centroid I'm just going to take the average of all the x's. So let's see, I've got 0, 5, and 2. So I'm going to do 0 plus 5 plus 2. And what am I going to divide by? Divide by 3. I'm taking the average. I'll do the same thing with the y values. The y values are negative 3 plus 0 plus 4. And I'll divide all those by 3. If I take these averages, that should give me the centroid. Okay? Well, 5 plus 2 is 7. Let's just leave it as a fraction. Don't make a decimal. Let's leave it as a fraction. So that will make 7 over 3 will be the x value of my centroid. Let's see. If I do negative 3 plus 4, that's 1. So that'll be 1 over 3. So there it is. These are the coordinates of my centroid right there. Any questions about that? Let's test it out. What is 7 over 3 as a decimal, you guys? 2.3. And of course, 1/3 is approximately 0.3. Let's plot that point on the graph and see if it looks like the center of the triangle. So 2.3 comma 0.3. So if I go over 2.3 and I go up 0.3, that would be right about here. Okay? This point would be the centroid of the triangle. So just add that to your memory. The centroid is the one that you can just take the average of the x's and y's. So that's number 2. Number 3. A student wants to inscribe a circle inside of a triangle. Which, without even reading any further, which is the one that you get when you draw a circle inside the triangle? That's the incenter. So again, you need to commit all this to memory, but just cheating for now and looking at our notes, if we scan these, look at incenter. Look at item number 2 for incenter. If you draw a circle inside the triangle, touching the sides, the center of the circle is the incenter. Incenter is the one with the circle inside the triangle. Okay? So, you know that we're talking about the incenter. Now, but when we look at our options, it doesn't just say incenter. It describes how to build the thing. So we need to look back again. How do we build the incenter? Angle bisectors. Okay, so imagine that you have memorized everything on this paper, then you would know incenter is made from angle bisectors. So, if we look back, we are looking for the angle bisectors of the triangle. That's how we know that it is C. Alright? So the answer is C. Okay, look at number 4. J constructed a line segment from each vertex that was perpendicular to the line containing the opposite side of the triangle. At what point of concurrency did the lines meet? So he said he went from vertex, and then he went perpendicular to the line. Vertex, perpendicular. Look at these pictures. Which one of these 4 pictures is doing what he just described? Is it the first one, second, third, or fourth one? Okay. So I hear some people saying the second one. Okay. Let's talk about that one first. Each line goes from a vertex. Is it perpendicular to the other? It's not perpendicular though. So it goes vertex but not perpendicular. So it's not that one. What else? Which one do you say now? Okay, let's look at the third one. Each one starts from the vertex. Is it perpendicular at the other side? How will I know this is perpendicular? What kind of a little shape do I usually put here if it's supposed to be? There'd be a little box here telling you that it's 90 degrees. So it's not the third one either. They don't have to be perpendicular. What does that leave? How about the fourth one? Okay, which is, I know you were saying the whole time. If you look, each one of these lines goes from a vertex, but then they make sure that it's perpendicular to the opposite side. Vertex, perpendicular, vertex, perpendicular. They are describing the fourth one. They are describing the orthocenter. By the way, these little lines, that's what altitudes are. Altitudes go from a vertex and they're perpendicular. Okay? So basically you have to recognize it in any form, either by name, orthocenter, connect it with the word altitudes, connect it with the picture, what they look like. Okay, so this one was orthocenter, because it was that fourth one that was being described. All right, basically if you memorize the sheet, you should be fine. Okay, look at problem number 5. Problem number 5 is a little bit different than the others. All right, we've got these vertices. We need to prove that this thing is a square. Look at the other side of your notes for a second. What's the definition of a square? What do we need to show? All the sides are equal, right? Okay, we need to show that all the sides are equal. If you look at that, if you look at your notes, a square, the definition of it. What does it say in the box? What's the definition in the shaded box? Right, this has to have 4 congruent sides and 4 right angles. Okay? Because it's got to be a rhombus and a rectangle. So basically that's what we have to prove. How can we show that the sides are equal? Do you guys remember this? How do we show that the sides are equal? The distance formula. Okay, we have to remember the distance formula. And the distance formula went like this. Okay? In fact, wait, let me go back a step. I'm going to do it like this. Remember how we would do? We would say, okay, let's do PQ, and then we do QR, and I will do RS, and then I will do PS. All right, these are the 4 sides of the square. And I will just do the distance formula 4 times. Okay, so for example, so remember, this is the distance formula right here. Okay, you should probably write that down to remind yourself. So you could just type this whole thing into your calculator just all at once, which is kind of what I recommend. And then that gives you square root of 26. Okay, so that one was square root of 26. Okay, so the next one would be like this. You could just type all that in your calculator. Again, we get square root of 26. Okay? All right, now just for the sake of speed, can we just pretend that we did that 4 times? And guess what? We get square root of 26 every time. Okay? Now I'm skipping ahead, but for your homework, you make sure you do all 4. Okay? So we've proved that all 4 sides are equal. Does that mean it's a square already? Not yet. We haven't proved about the 90-degree angles yet. How do I prove that I have 90-degree angles? The slopes, right? Is that what you said? Now, you guys, I could use the slope formula. Remember, slope was like y minus y over x minus x. I could calculate the slopes. but I'm given the picture, so it might be easier just to find the slopes from the picture, okay? Remember, the slope is just rise over run. So look at PQ. Let's talk about the slope. It's up 1 and over 5, okay? So the slope of PQ is 1/5. All right, let me record this. All right, so I'm making a little chart. So we did length, and now I'm doing slope. Okay, so the slope of PQ was 1/5. Now, let's do the slope of QR. So here's QR right here. This goes down 5 over 1. Down 5 over 1. So what kind of a slope is that? If I do 5 over 1, what does 5 over 1 reduce to?
5.
Just 5. Now, because it's going downhill, what do I need to put in the front here? It's negative. So the slope of QR is -5. Do you guys remember about if it's uphill, it's positive, if it's downhill, it's negative? You guys know that? Yes. How to get 1/5? Going from P to Q, I had to go up 1, that's the 1, and over 5. Okay, rise over run 1/5. Yes, ma'am? Okay, we're doing rise over run, correct? So when we do QR, what's the rise? Say again? Okay, looking between Q and R, the rise is the vertical change, okay? This is the rise right here. This is the vertical separation between Q and R. Is that 1? That's 5, okay? The rise is 5. The run is the horizontal change, okay? So that's why it's 5 over 1. If you compare that to this one over here, the vertical change between these two, the rise is 1, and the run is 5. Okay? Does that help? Okay. So real quick, so the other ones. If I want to look at RS, that's this one down here. RS, the rise is 1 and the run is 5. So this again is 1/5. Uphill, positive 1/5. So I'll write that down, positive 1/5. And of course PS is down 5 over 1. So again, that's -5 over 1, or just -5. Now, once I have all the slopes, how can I tell, how do the slopes prove that the lines are perpendicular? I'm looking for 2 words. Does anybody remember? That's close. That's one of the 2 words, okay? Denzel said reciprocal. They're reciprocal. They're also, say it again, opposite. Okay? That's what it takes to prove that 2 lines are perpendicular if we're talking about the slopes. They need to be opposite in sign. So if I look at any 2 of these, if I look at these, one's positive, one's negative. That's the opposite. And they're also 1/5, 5 over 1. They're reciprocal. So that's the key. These are opposite and reciprocal. So that's what proves that they are perpendicular. So perpendicular, perpendicular, perpendicular. So that now we've proved that it's a square. Okay? All right, look at number 6. Okay, so we know that SR is 30. So let's put 30 down here. And we know that ST is 17. So I'll put a 17 right here. Okay? Let's see. This is a rectangle. So let's do this. Look at ST. Since ST is 17, can you tell me what TQ is going to be? 17. TQ is also going to be 17. All right? This is the key to the problem. So everybody watch this very carefully. Concentrate on this triangle right here. Okay? All right? Focus on this yellow triangle that I just made. If we can do the Pythagorean theorem on the yellow triangle, that will give us the side of the rectangle. That's the key to the problem. So, because I've got the double 17, what's the total length that I just found? 34. That means this total length right here is 34. Okay? So we can just do the Pythagorean theorem now. So I'll just call this x for a minute. So what I have is x squared plus 30 squared equals 34 squared. All right, a squared plus b squared equals c squared. So that makes x squared plus 900 equals, help me out, 1,156. That's not right? It is right. Then I'm going to subtract 900 from both sides. Okay, need a little space. So that's going to give me x squared equals what? 256. 256. Then I'm going to take the square root of both sides. And that's going to give me what? 16. X equals 16. Okay? So that means this is 16 over here. Now, is that what I was supposed to find for my final answer? No. What am I supposed to find? We're supposed to find the perimeter. Okay? We're being asked to find the perimeter. But now I've got the 30 and the 16, so finding the perimeter is going to be easy. Okay, so the perimeter is going to basically be, 30 plus 30 plus 16 plus 16. Okay, because this is 30 and this is also 16. So what does the perimeter come out to be? 92. Okay. So that is how you do number 6. All right, number 7. Which of the following proves that this thing is a parallelogram? Well, some of these just don't even make any sense at all, but if it's a parallelogram, the angles that are right next to each other should be supplementary. That will only happen if it's a parallelogram. So, for example, if you look at angle G, is angle G supplementary to angle H? Are those supplementary? Yeah. Add them up and tell me what you get. 180. They told me it adds up to 180. Did you try it? These two, the 34 and the 146, I think they add up to 180. What about well, obviously it would be the same thing for the other one as well. So if angle G is supplementary to both of the angles that it's next to, then that should prove it's a parallelogram right there. So that's why the answer is A. If you look at the rest of these, they don't prove it's a parallelogram. Look at number 8. Isosceles trapezoid. What does it mean for this trapezoid to be isosceles? Isosceles? The key about isosceles is these two sides should be congruent. That means the whole picture has symmetry. It has balance. So all of these pieces should be the same. For example, x minus 1 should equal what? What? No. These two won't be equal. The x minus 1 and the 2x plus 2 won't be equal. Right. These two should be equal, for example. X minus 1 should equal 2x minus 3. The symmetry line is like right down the middle. These two sides should be equal. So if I had wanted to, I could have done this one instead. 3x should equal 2x plus 2. So these go together, and these go together. All right? Wait, why did I do that? Okay, so x minus 1 should equal 2x minus 3. I'm just going to go ahead and use that one. So if I wanted to solve this, I would subtract x from both sides. That's going to give me negative 1 equals x minus 3. Then I would add 3 to both sides. Now I get x equals 2. Okay, now that's not the answer to the question though. They didn't ask me to find x, did they? What did they ask me to find? They asked me to find the length of QS. So I'm not done. So I need to take this 2 and plug it back in. I need to plug it in here and here. Okay, if I take this 2 and I plug it in, that's going to give me 2 minus 1, which is what? That's just 1. And if I plug it in here, that's going to give me, okay, that's going to give me 4 plus 2, which is 6. Okay, so the total distance from Q to S is 6 plus 1. Okay, so QS is equal to the 6 plus 1, which of course equals 7. That's why the answer is C. Any questions about number 8? Okay, look at number 9. Given a rhombus, remember, what's the main thing about a rhombus? It has 4 congruent sides. We should probably draw a picture of this thing, though. We're given a rhombus. Let's draw it real quick. This would be a rhombus. Okay, there's my rhombus. Let's see, this is supposed to be A, B, C, D. So here I go, A, B, C, D. There's my rhombus. CD is 2x plus 6. So this is 2x plus 6. Okay, and I'm supposed to, oh, then they told me the perimeter was 72. And I'm supposed to find x. Well, what's the perimeter? How do you find the perimeter of a shape? You add up all the sides, okay? So if the perimeter is 72, that means if I add up all the sides, which would be like doing 2x plus 6. Now I could sit here and do 2x plus 6 plus 2x plus 6 plus 2x plus 6 plus 2x plus 6. Or I could multiply. What would I multiply by? Couldn't I just multiply by 4? That would just be a little quicker. Does that make sense, Margaret? So instead of doing plus, 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 I will just do times 4, because there's 4 of them. And that should equal 72. Is that cut off? That's cut off on your screen. Okay? I multiplied it by 4 because there's 4 of them. So let's see. Little distributive property now. That will give me 8x plus 24 equals 72. Subtract the 24 from both sides. Alright, I heard 8x equals 48. Divide by 8 on both sides. 6. That's why the answer is D. Alright? Did you follow that, sweetie?
Yeah, I just did it different, but I got the same answer.
Okay. However you did it is probably totally fine. Okay? Look at number 10. Find the missing angles. Based on the markings, we see that this is an isosceles trapezoid. That means these angles should be the same. So what's the measure of angle K over here?
60.
That should be 60. Okay? They should be the same. See the symmetry, the balance? The left and the right should be the same. So angle K is 60 degrees. Now, how will I find angle J? 180 minus 60. Okay, because these will always be supplementary. What is that? 120. Okay, so angle J is 120. So what's angle M? It should also be 120. Okay, look at number 11. Same type of thing. This is a kite. Look at the picture and tell me what angle T must be. It must be 113. You see the balance. The line of symmetry goes right down the middle. So the left and the right should be the same. So angle T should be 113 degrees. Is angle W going to be 37?
No.
No, they're not the same up and down. So what will I do to find angle W? Add them up and do what? 360. Remember, in a quadrilateral, they have to all add to 360. So if we start from 360 and go minus 113, minus 113, minus 37. Just subtract everything from 360. What do you get? 97. So that's 97 degrees. Okay. Looks like we're down to the last one. Number 12. ML is 4. So this is 4. LN is 10. So this is 10. Find LO. You're supposed to find LO. Well, what's LO going to be? Yeah, this is a kite. So there's symmetry. So LO is going to be 4. Alright, I was all ready to do the Pythagorean theorem or something, but it's just 4. Okay, any questions anywhere on this entire sheet?